third pillar of object-oriented programming. Okay, and the fourth pillar is like what? Abstraction. Okay, so we have like four pillar of, you can say that, of object-oriented programming, that is encapsulation, uh, inheritance. Third is polymorphism. Fourth is abstraction. Okay, so in this class, we will try to cover all the things. Okay, so should we start? Okay, so before proceeding further, let us first discuss today's learning objective. So yes, these are the today's learning objective. Okay, so by end of the session, a learner will be able to understand the concept of function overloading. Okay, what is the function overloading? Okay, in the previous class we have described like what is function uh, overloading. Okay, in this class we will describe what is function overriding. Okay, and we will explain the runtime polymorphism in C++. Okay, so yes, and so explain the runtime polymorphism in C++ and understand the concept of the abstraction in C++. Okay. What is the abstraction and why it is used and how it is used, how we can implement in the object-oriented programming. Okay. And explain the why the abstraction is required in the programming. Okay. And identify the ways of achieving the abstraction in C++. So let's proceed with what? So we have discussed what is polymorphism. Okay, so polymorphism is like what? Uh, Many forms. Okay, so it is have two types: compile time polymorphism and the runtime polymorphism. So runtime have like two types: function overloading and operator overloading. We have discussed these things already in the last lecture. Today we will cover this topic. Okay, function overriding. Okay, so function overriding is a part of what? Runtime polymorphism. Okay, so yes, so it is implemented using the virtual function. What is virtual function? We will like discuss this thing in today's lecture. Okay, one by one. So yes. So now let us talk about function overriding. So you can we can understand with the example like if you have like if you in your home, your parent have a car that is a petrol car, that is a old model car. Okay, that car is like what? You can say this is a Toyota car. Okay, some Toyota car it is. Okay, now you want to purchase a new car. Okay, the same model. Okay, that is also Toyota. Okay, the same company car you want to purchase, but you want to add like some other functionality in that particular car. Like this is like what petrol car, and you want to purchase some new car. This is like wow, that is electric car. Okay, electric car. Okay, you want to purchase a electric car. So the thing is like, okay, so function overriding is nothing but if a parent have like same function, okay, same name, same parameter, and you do not want to use that parameter or that function, okay, but you want to implement your own function, okay, with the same name and the same parameter. Okay, so this is we call like function overriding. Okay, so overriding means a child class like create a Toyota car, okay, and that is electric. Okay, functionality should be like what? Electric. Okay, so this is like what? Electric. Okay, so the function overriding occurs when it is occurred a derived class define a function. Okay, when a child class or the derived class define a function that already exists in the base class. We are defining a function. Okay, we are defining a function in the child class or the base class that already present in the base class. Okay, that already present into the base class with the same name. Okay, suppose if like a function we have like add function. Okay, and it is taking two parameter like integer x y. So if we have a function in child class, okay, in that we have integer x comma integer y. Okay, so we have like defining this same function in the base class. Okay, the base class also have a function add. Okay, it is also taking uh, two parameters. Okay, no difference between like name or the number of parameters or the number of like what type in the types also. Okay, we are the child class is defining the same name, same parameter, same data types function in the child class with the different functionality. So suppose it is adding two number. Okay, so it is adding two number, but this child class wants that this add function work like some extraordinary work. So right, it can be like instead of adding, it is like what it should do multiplication. So this add function, like what will it will do? This will multiply the two numbers. Okay. So what is the function overriding? Function overriding occurs when we are defining a new function. Okay. In the derived class, we are defining in the child class, we are defining with the same function name and the same parameter. Okay. Function name and parameter and the type also. Okay. And types of the parameter also will not be changed. Okay. So now you can think that logic. So which function will be called at runtime? Okay. So the it is like what function overriding. So function overriding is a type of like what runtime polymorphism. So runtime polymorphism, like which function should be called at what time? Okay, it is decided by the not compiler, decided by the processor. Okay, so which function should be called at like we are calling add function. So which function should be called? Either child class function should be called or the parent class function should be called. So this is decided by the whom? The processor or the runtime it will be decided. Okay, so this is all about the runtime function overriding. Okay, key requirement of the function overriding is like what? First thing is like inheritance should be there. Okay, there should be like a base class, there should be a derived class also. Okay, and the second thing is like what? Same function name. Okay, so in the parent class, okay, in the base class and the derived class, in the parent class, in the base class and the derived class, the first thing is like there should be like inheritance property. So first thing should be required, that is inheritance property. And the second thing is like what? Inheritance. Okay, second thing is what? Function name. Okay, so function in like what? Both have like same function. Okay, suppose I am writing a add function. Okay, so add. Okay, and this is also having a function whose name should be add. Okay, and the third thing is like what? Parameter list. So same parameter list should be have. It is suppose it is having two parameter. So this should also have two parameter. Okay, okay, and the same return type. So here what is the return type? Okay, that should also be same. Okay, so whole thing should be same. Okay, but the internal implementation can be differ. Okay, as per the user requirement. Okay, so user wants that this is implementing some other things. So why this properties require at the runtime? Okay, why this properties require? Okay, suppose the parent class, the add function doing some other stuff. Okay, but in okay, it is adding to number. Okay, uh, in the derived class, we want to like not use the same property. We want to accelerate that like property. Okay, you can say that. Okay, so if your father giving you a family business, okay, you are using your father business name all the things. Okay, so आप अपने father का जो है parents का all like setup like company name, company building and all the facilities you are using of your father. Okay, legacy you are using, but you want to accelerate that all the things. Okay, you are not stuck at the particular point. Okay, you want to expand your business and all. So then business name is same, all the things are same, the properties, all the things like land and all the properties and you are using that is same. Okay, but you are expanding that a particular business. Okay, so that's why this model is implemented. Okay, so this is like what? Function overriding. And so this is like what? Key requirement for function overriding. Now let us talk about why function overriding is required. That is I already told. So the function overriding occur like achieve at the runtime polymorphism. Okay. So it allows the derived class to provide its own implementation. Okay. So function overriding function overriding allows, okay, derived class to provide its own implementation. Okay, it improves the flexibility and the extensibility of code. It improves the flexibility and extensibility of code. Okay, so as I already told, if the derived class wants its own implementation, this implementation to like derived class do not want, so we can use that particular property. Okay, it improve the flexibility. Okay, because we are using the same name, same parameter, all the things. Okay, so we can understand with the help of like what real time example, that is like we are creating a class that is vehicle class. Okay, vehicle class. Okay, we have vehicle class. So this vehicle class, okay, have a function that is start. So it start is a what behavior of a vehicle. Okay, so it is like what we are printing like the out start this vehicle. Okay, vehicle is starting and some kinds of stuff will be there. Okay, now we are the car class is derived by and inheriting the property of vehicle class. So we are creating another class that is car. Okay, and that particular class is inheriting the property of vehicle. Okay, it is inheriting the property of vehicle. Okay, public vehicle, and it's have also a start function. Okay, so the car will be like start if it is a what we can say that electric car, so it will be start with the button, or the you want to start with the key. So we have like own flexibility. Okay, so here like starting with key. Okay, here we are implementing like start with the push button or like some key button. Okay, okay, so this is like property of function overriding. Okay, so why the function overriding is required? What is the requirement of the function overriding? Okay, so we have discussed these things. So now let us understand with the help of the example. So you can see here the example. Okay, so we have here a base class. Okay, in the base class, so forgot what is a virtual right now. Okay, so that thing we will discuss later. Okay, don't be confused. Okay, so yeah, so this is like what we have a base class. So base class have, this is a base class. Base class have a show function. A show function have, okay. So this is a base class that is function having function show. Okay. Now we are deriving a class. Okay. This is a base class. Now we are deriving a derived class. This is using the property of this. If we are not declaring any show function here, so by default, so it can be access this show function. Okay. So because of the inheritance property, it can be access this kind of this show function. Okay. So, but the derived class wants that its own show function. Okay. So like having the same parameter and the same name. Okay. So it is having same thing. Okay. So this is derived class. Okay. And having the same show function with the, now if we are declaring like a base class, okay, object, this is like a what derived class object. Okay. So which function call should be like which function should be call of the class? So either this or this function. Okay. So this is decided by the not compiler. It is decided by the runtime polymorphism. Okay, so processor will be decide which function should be bind at which function definition. So this is the work of like what processor. Okay, so now let's move on and understand with the help of the example. So should we go on to the VS Code? Let me open the VS Code first. I am opening VS Code. Okay, and just a second. Yes. Is it my screen is visible? Is my screen is visible? Kindly write in the chat box. Devesh saying no. I think it should be visible. Now it is visible or not? VS Code screen. Okay. So this thing we have discussed into the previous class, like we have like this is like what function overloading example we have discussed in the previous class. Uh, Now I am giving this. Okay. Now we have only okay. So one class we have that is calculate. Okay. So uh, now we are declaring like second class that is class. Okay. Addition. I create the addition class. Okay, the name of the class is addition, and it is inheriting the property of uh, publicly inheriting the property of calculate class. Okay, okay, this is the property of calculate. Okay, so public, I am declaring some another stuff, not the add function like void show. Okay, yeah, yes, yes. Okay, so we are printing the property of if we have here integer x and integer y. Okay, so kindly assign x equal to a plus and y equal to b x plus y. We are written. Okay. So what I am doing here, what I have done, so I created a class. Okay, that is calculate class. It containing two members, that is x and y, and it having like one function that is integer add function. Okay, so it is taking two parameter that is integer a, integer b. Okay, so we are assigning this thing to the x and y, and we are written addition of x plus y. Okay, and we have take another class that is addition. Addition is like what child class, or you can say the derived class. It is inheriting the property of the calculate class. Okay, it is inheriting the property of calculate class. Okay, so mode of the inheritance is public, and here the access specifier for the addition class is also public. Okay, so we have defined like another void show function. Okay, till now this is only like what the simple inheritance. Okay, it is nothing like what function overloading, function overriding is nothing is performed till now. It is simply what it is simply show. Okay. Uh, yes. If here I created like what object of, I am creating the object of addition class. So addition is a class. So addition class have like what object. Okay. So addition have like we are having object. So yes. So you can observe one thing. Okay, in the addition we don't have like what add. Okay, but still we are using the add function because of like inheritance. Okay, so this is like what parent-child relationship. So that's why we are adding what we are using add function and passing what like 10 and 20. Okay, so after that we are also printing like what we are calling object dot show. Okay, so we are doing these things also. Okay, now I save this program. Now think the logic, okay, here carefully. So this object dot add function, okay, because uh, at the compile time it will be decided. So which function should be called? Okay, because it is not here. The object is of addition class. So addition have no not have like what add. Okay, because it is inheriting okay of the calculate class property. So the compiler will find out whether the add function is present or not. So it will find out there is a add function. So it will bind. So it will bind the this function call to this function definition. Okay. Now, so this because this is the object of the addition class. So firstly, it will goes here and it will check whether the show function is there or not. So because the show function is already here, so it will bind this function call to this function definition. Okay. So I'm saving this program. Okay, and you will find out. Let me compile this g++ demo dot cpp. Okay. So it is giving error. Why it is giving error? Anyone can tell me why it is giving error? Why we are not able to access X and Y? Because I declare wrongly here. Okay, it should be like that. Okay, it should not give error right now. Okay, no error. So why is declare? Okay, Devesh. But here I write like two times. Okay, so declaration is not the correct format. That's why it was giving error. Okay, now it should be not give error. Okay, so no error right now. Okay, let me compile this. Compilation successful. Now we are executing. Okay, so you can see here, uh, we are not like what we are doing. We should write here and then. Okay, I write here and here also we are writing and then. Okay, so it should be clear. We should be what should we call? Okay, so the addition is 30. Okay, first this is because this is a object of the derived class. Okay, it is using the property of base class. Okay, parent class property it is using. So this is like what inheritance, simple inheritance we are using here. And okay, now this show function is having this show function. This show function is calling like what? This show function calling this class. Okay. Now we want that the add the same function we want like integer add. Okay, now it is taking same parameter integer a comma integer b. Okay, same number of parameter and same type of the parameter we have. Now we are performing like some we are changing the implementation at the time of here. We are like printing we are doing like not do the addition. We are doing here multiplication. Okay, so this message will also be printed. Okay, and we will return what? We will return simply uh, a multiplied by b. Okay, so we are not doing the addition. We are just like what we are doing multiplication. So this is like what child class implementation. Okay, so it is using the same name, same parameter. Okay, now at this time, okay, at this time this will goes here. Okay, and it will bind with this particular thing. Okay, so now you can see here demo.cpp successfully compiled, no error. So you can see here we are passing two number 10 and 20. Okay, so it is printing no not to do like what addition. We are doing like what multiplication, and it is multiplied 10 and 20, and this is like what garbage value. Okay, because this function is not called and value is not into the x and y, so that x and y value is printing garbage value. Okay, so this we are calling like function overlapping. Okay, so this function like this add function is overlapped by this add function. Okay, so this is like what function overriding or function overlapping. Now one fact I want to tell you. Okay, I want to tell one fact to you. Okay, so let me goes on to the slide, and after that I will explain like what the fact. So yes, so there is one fact. Okay, that is, so if we have like pointer base class pointer, or you can say that parent class pointer, we have a parent class pointer. So parent class pointer, okay, can have the address of any descendant class. Okay, so like it can have like this is like pointer of the parent class. Okay, so this is like what PTR is a pointer of type what base class. Okay, so it can have like address of the class base and its descendant class. Okay, like it can have like address of this class, and it can also have like address of this derived class. So the base class pointer, so base class pointer can have the address of the base class and the descendant class. Okay, like it can have like address of derived class also. Okay, it can have address if we are using multi-level inheritance. Okay, suppose we have a class and B class. Okay, so this we are calling like just let me erase this. That it will be clear for you. Yes, if we have a class, okay, that is a class, okay, and we have another class that is B class. So B class is inheriting the property of A class, and the C class is inheriting the property of B class. Okay, so if we are using the pointer, so a class pointer we are creating that is PTR. So PTR can have like address of the object of A class. Okay, it can have like address of A class object. Okay, or the B class object or the C class object. So the pointer of this can be point like object address of this, the B class or the C class or the descendant class. Okay, so of class C. So class C, okay, we are declaring pointer of class C. Okay, this class pointer. So this class pointer cannot have like what एड्रेस ऑफ दिस क्लास ऑब्जेक्ट। ओके, सो बी क्लास का जो ऑब्जेक्ट का एड्रेस है वो क्लास सी का जो पॉइंटर है वो पॉइंट नहीं कर सकता। ओके, बट जो क्लास बी का जो पॉइंटर है कैन पॉइंट टू द can have like address of class C. So one thing you have to learn. Okay, so let me practically give you the clarification. So here now let me clear. We have like calculate class. Okay, so this font size is visible or not? Is this font size is visible, or should I increase the font size? Please write in the chat box. Is this visible or not? Okay. Uh, calculate. Okay. So here we are using calculate class and we are creating the object C1. Okay. So we have created the C1 class object. Okay. And now we are having another class that is addition. Okay. And the addition class object A1 we are creating here. So this is like C1 object of the class calculate. It is addition object of class A1. And I am creating a pointer addition. And this is like what pointer PTR of A1 object. Okay. Or it can also have like can have the address of C1। ओके, जो ये पॉइंटर है एडिशन क्लास लाइक नॉट एडिशन क्लास, सॉरी, द कैलकुलेट क्लास। So the calculate class pointer can this is a PTR is a pointer of calculate class can have like address of the C1 class. Okay, can have the address of the C1 class or the A1 class. But the addition class pointer like derived class pointer cannot have like address of C1. Okay, so you will find out. This is like we have the pointer two. Okay, not this time we are creating a pointer of addition class. Okay, so addition class pointer will have we are assigning C1. Okay, so are you getting my point? What I'm trying to do here? Yes. So okay. Let us check what the final output will be here. Okay. So you can see here where the it is giving the error. So it is giving error at which line? Here. So addition class like pointer PTR2, we are assigning the address of C1. Okay. So addition class, okay, pointer. Okay. So here we are in the addition class pointer, we are assigning the address of calculate class. So the derived class pointer, we are assigning the base class object address. So it is not permissible. Okay. But the base class pointer can point to the can have like address of any derived class object. It is like what parent child class object. Okay, so it is pointing by the calculate class. Now, okay, so here is the logic is coming right now. Okay, so this is like what pointer. This is like what pointer of which class calculate class. Okay, which class calculate class. it is having the address of A1 class. It is having the address of addition class object. Okay. So let me again go here and just a second. Just a second. Okay, and let me pause. So I am sharing the VS Code right now. Yes. We have font size 14. And this thing I am deleting right now. So yeah, now it will be good. Yes. Let me share the again. Yeah. Now you can see the code on the slide from the current slide show. Okay. So here, what we are doing. So we have a class, what calculate class, and we have addition class. So this calculate class have a pointer. Okay. We are created a pointer PTR. Okay. And this is having like what add function. It is having what add function. And we have like what addition class. Okay. And this is also having what add function. So and the calculate class having the address of the object. The pointer is having the address of this base class. Okay. So ideally it should call to this function. Okay, because it is having like what address of A1, uh, that is the object of the addition class. Okay, when we are calling like ptr, okay, ptr, we are calling ptr dot addition function. Okay, so this should be bind with this. Okay, ideally it should be bind with this. Okay, because it is having the address of A1. Okay, addition class object. Okay, because the pointer is having the address of A1 class object, but it is the binding. Okay, so this error we got and the runtime polymorphism. So to resolve this kind of error, we are using what virtual function. Okay, Now here, okay, we are assigning the address of addition class object to the base class like calculator class pointer, and we are calling the ptr, okay, add function. Okay, so the ptr function should call like this function. The ptr function should call this add function, but the ptr will call whom? This add function. Okay, let me print here. See out, we are printing. Function is calling. Okay, I write here and then okay, this is done. So let me clear this. Yeah, yeah. So now let me compile this program. Here we have to pass like two argument, like I am passing 10 and 20 because the two arguments should be passed. Otherwise it will give the error. Okay. So you can see here the calculation class add function is calling. So this is like what it is calling. Okay. So this class is calling. Okay. The parent class is calling because the parent class pointer, this is like what parent class calculate class pointer is pointing to, having the address of the addition class. At the compile time, the compiler is binding based on the type of the pointer. Okay, it is pointing to. Okay, so because the ptr is like what the calculate class, so the compiler is binding the add function, or okay, so this add function to the calculate class. Okay, function definition, because but it should bind with the this add function because the pointer is having the address of the addition class. Okay, so it is not happen. So that's why we are using here virtual. So let me write here virtual. Okay, now you will see the magic. Okay, we are just using here what virtual. Okay, we are just using here what virtual. So I did not change anything. Okay, so previously it was, let me write here addition class. Let me save this program. Okay, so what I add here just virtual. Nothing. I did not change in this code. So after adding the virtual, okay, after adding the virtual, you can see here, I did not change anything, just add virtual. This add function is calling right now. Okay, this add function is calling right now. Okay, so why this happen? Okay, what is the power of this virtual? Okay, so what is the concept behind it? Okay, so this is like we will understand right now. Okay, so let me clear one theoretical part here. So if I remove here virtual, okay, so what what will be called? So it will call like the base class addition function. Okay, if I remove the virtual, if I am using the virtual here, okay, so it will call this add class function. So what is the concept behind it? Okay, let me tell you this thing. Okay, so the base class pointer, the base class pointer having the address of the child class object. Okay, so the compile here we are calling with the help of the pointer. Okay, so at the compile time, okay, at the compile time, compiler is binding this function calling. Okay, so who is calling this function? this function is called by this pointer. Okay, so at the compile time, the compiler will bind this add function by checking, by looking the type of like what, the pointer. So what is a pointer type? Pointer type is calculate. So it will bind the pointer add function. Okay, if it will be bind to the pointer add function. Okay, because both have like parent have. Okay, so the compiler doing this thing. Okay, so this is like what, compile time binding. Okay, now we have to do like what, runtime binding. So we are using the virtual keyword. Okay, so virtual keyword is giving the instruction to the compiler to bind this Yeah, because of like some internet issue, I disconnected with this meeting. Let me share again like what VS Code and yes, just a second. Yeah. So here I'm telling you that thing. Okay, the compiler will tell the compiler that this virtual function we are using here. Okay, so when we are using this virtual function, okay, so this when the compiler is binding with this addition function definition, so this virtual will tell that okay, so don't bind with this. Okay, so kindly find into the like in the descendant class or the child class if the add function is available or not. So it will at the runtime, okay, so it will find the there is a add function present into the child class. Okay, so the runtime at the runtime the processor will bind this add function function add uh, with this function definition. Okay, so this is like what the concept of the virtual function. Okay, so if you have any doubt in it you can ask. अगर आपको कोई भी डाउट हो तो आप पूछ सकते हैं. So what is a virtual function? Okay, so virtual function is a member function that is declared using the virtual keyword. Okay, and it support the dynamic binding. Okay, it support the dynamic binding. We are doing like what, dynamic binding. Okay, at the runtime it is performing. Okay, it's ensure the correct function is called at the runtime. Okay, the correct function should be called at the runtime. Okay, if we are not using the virtual keyword or the virtual function, so uh, based on the type of the pointer, the compiler will be bind the function definition to the function calling. Okay, at the time of the function calling. So this is like what. Uh, so here we are declaring the virtual. Okay, so this will become like what, virtual function. This will become what, virtual function. Okay. So do you have any doubt in this? Then you can ask. If you have, Gungun, Divesh, Radhe, Arush. So in this session, like we have discussed till now, function overriding. We have discussed the concept of like what virtual and runtime dynamic binding. What is dynamic binding? Okay. So if you have any doubt, you can ask. I'm here to listen your queries right now. Okay. We are ending towards our syllabus. Okay. We have completed our three things like encapsulation we have completed. We have completed polymorphism. We have so this is like what end of the polymorphism. We have completed like what uh, inheritance we have completed. Okay. So three module we have completed. The fourth module of the object-oriented programming, the fourth pillar is abstraction. So that thing I will discuss into the next class because today we have not sufficient time. Okay. So I want to give this time to the discussion. So if you have any doubt, any query, so you can ask here. Okay. So yeah, now up to you. Gungun, Divyesh, Radhe, Arush, Samarth, Kale, Yogita, Ranojit, Tata. So if you have any doubt, you can ask. I am not receiving any response from your side, guys. Arush, Divyesh, Khushbu. तो अगर आपको कोई भी डाउट हो तो आप पूछ सकते हैं. Any type of doubt you have, then you can ask. So kindly tell Gungun, are you there? Divyesh, Radhe, Arush. If you don't have any doubt, then you can leave this session. That's all from my side. Okay. So thank you. Happy learning. Keep learning. Okay. Pranajit, Prosojit. Sorry for the mispronunciation. So the yeah, that's all from my side. Okay. In the next class we will discuss like what abstraction. Okay, and after that we will do the some practical things. Okay. I have done the all the things with the help of the practical on the VS Code. Okay. So next class we will discuss like what abstraction. Okay. So thank you. Till that, keep learning.